Hey everyone, tonight we're going to dive into something that's been quietly orchestrating cosmic events in our solar system for billions of years. The intricate dance of planetary alignments and the silent stories they tell about our celestial neighbors. When we look up at the night sky, we're witnessing the culmination of gravitational choreography that began when our solar system was nothing more than a swirling disk of dust and gas around a young star. Planetary alignments aren't just pretty arrangements of dots in the sky. They're windows into the deeper mechanics of how worlds influence each other across vast distances, how ancient civilizations interpreted cosmic patterns, and how these celestial events might be connected to phenomena we're only beginning to understand. Every time planets line up in our solar system, they're creating gravitational resonances that ripple through space, affecting everything from asteroid trajectories to the behavior of our own planet's magnetic field. What makes these alignments particularly intriguing is how they seem to occur with a precision that suggests underlying organizational principles operating within our solar system. The planets don't just wander randomly through space. They follow orbital patterns that create recurring cycles of alignment, conjunction, and resonance that repeat with mathematical regularity across centuries and millennia. Consider what happens when Jupiter and Saturn align, as they do roughly every 20 years. These two gas giants represent more than 99% of the planetary mass in our solar system beyond the Sun itself. When they come together in the sky, their combined gravitational influence creates subtle but measurable effects throughout the entire solar system. Asteroid orbits shift slightly, comet trajectories bend, and even the orbits of the inner planets experience tiny perturbations that accumulate over time. But the story becomes even more fascinating when we consider the longer cycles. Jupiter and Saturn don't just align in the same general direction, they align in different parts of the sky, creating what astronomers call the Great Conjunction Cycle. Every 800 years or so, these alignments return to roughly the same celestial coordinates, creating a cosmic rhythm that ancient astronomers tracked with remarkable precision. The Maya calculated these Jupiter-Saturn cycles with an accuracy that wasn't matched by European astronomy until the Renaissance. Their calendar systems incorporated not just the obvious cycles of the Sun and Moon, but also the complex interactions between all the visible planets, creating timekeeping systems that could predict planetary positions thousands of years into the future. It makes you wonder what they understood about planetary influences that we've forgotten or overlooked. Ancient Chinese astronomers took this even further, developing theories about how planetary alignments influenced earthly events through what they called the mandate of heaven. They believed that unusual planetary configurations signaled important transitions in cosmic order, and they structured their entire political and social systems around these celestial observations. Their astronomical records, spanning over 3,000 years, represent one of the longest continuous databases of planetary observations in human history. But it's when we examine the more complex alignments, events involving 3, 4, or even 5 planets simultaneously, that we begin to encounter patterns that challenge our understanding of how solar systems should behave. These multi-planet alignments occur much less frequently than simple two-planet conjunctions, yet they happen often enough to suggest that our solar system has some inherent tendency toward coordination and synchronization. Take the alignment that occurred in the year 2000, when Mercury, Venus, Mars, Jupiter, and Saturn all appeared within a relatively narrow band of sky. Astronomers calculated that such a 5-planet alignment hadn't occurred for several centuries and wouldn't happen again for several more centuries. Yet during this alignment, multiple space agencies reported unusual activity in their deep space monitoring systems. Solar wind measurements showed anomalous patterns, and several satellites detected electromagnetic fluctuations that couldn't be explained by normal solar activity. These kinds of correlations between planetary alignments and unusual phenomena show up repeatedly throughout astronomical records, but they exist in a gray area between documented observation and speculative interpretation. Official scientific literature tends to treat them as coincidences, but the patterns are persistent enough to raise questions about whether planetary alignments might influence solar system dynamics in ways that our current models don't fully account for. The gravitational mathematics of planetary alignments reveal another intriguing aspect of these cosmic arrangements. When multiple planets align, they don't just add their individual gravitational influences, they create what physicists call resonance effects, where the combined gravitational field becomes greater than the sum of its parts. These resonance effects can influence the behavior of smaller objects throughout the solar system in ways that are difficult to predict using conventional orbital mechanics. Some researchers have proposed that these gravitational resonances might help explain why our solar system has remained stable for over 4 billion years. Most computer simulations of solar system formation suggest that planetary systems should be much more chaotic than what we observe. Planets should migrate more dramatically, asteroid belts should be more disrupted, and small bodies should be ejected from the system much more frequently than they actually are. The fact that our solar system has maintained its organized structure for so long suggests that there might be stabilizing mechanisms at work that we don't fully understand. Planetary alignments and the resonance effects they create could be part of a natural feedback system that helps maintain solar system stability by preventing any single planet from drifting too far from its optimal orbital position. This stabilizing influence becomes even more remarkable when we consider that the planets in our solar system seem to be arranged in what some astronomers call suspiciously regular orbital patterns. The spacing between planetary orbits follows mathematical relationships that appear too organized to be purely coincidental. The Titius-Bode law, discovered in the 18th century, showed that planetary distances could be predicted using a simple mathematical formula, a pattern that shouldn't exist if planets form through random accretion processes. Recent discoveries of exoplanetary systems have revealed that many other star systems show similar organizational patterns, suggesting that planetary alignment and orbital resonance might be fundamental features of how solar systems organize themselves. The Kepler Space Telescope has detected hundreds of multi-planet systems where the orbital periods of different planets show precise mathematical relationships, creating complex rhythms of alignment and resonance that repeat over cosmic timescales. These discoveries raise profound questions about the nature of cosmic organization and the role that gravitational relationships play in creating order from chaos. Our solar system isn't just a collection of isolated worlds following independent orbits. It's an integrated system where each planet influences the behavior of all the others through a complex web of gravitational interactions that create patterns, cycles, and alignments spanning millions of years. Tonight, we're going to explore what these planetary dances reveal about the hidden connections that bind our solar system together, examine the evidence that ancient civilizations understood these cosmic relationships in ways that modern science is only rediscovering, and consider what the silent stories of our planetary neighbors might tell us about the deeper principles that govern cosmic evolution and our place within it. To understand the profound significance of planetary alignments, we need to journey back to the very beginning of our solar system, when gravitational relationships first began shaping the cosmic neighborhood we call home. 4.5 billion years ago, our solar system was nothing more than a slowly rotating disk of gas and dust surrounding a newly formed star. Yet even in this primordial chaos, the seeds of the organized planetary dance we observe today were already being planted through gravitational interactions that would echo across cosmic time. The formation of our solar system wasn't a random process of matter simply clumping together wherever gravity happened to be strongest. Instead, it followed patterns that seem almost choreographed, with planets forming at specific distances from the Sun that create stable gravitational relationships with each other. The early solar system experienced what astronomers call the grand tack and late heavy bombardment periods, when the giant planets migrated inward and then outward again, sculpting the architecture of planetary orbits through gravitational resonances that persist to this day. During these migration events, Jupiter and Saturn created what researchers describe as a cosmic traffic control system that determined which planetesimals would become planets, which would be ejected from the solar system, and which would remain as asteroids and comets. The gravitational relationship between these two giants established resonance zones throughout the solar system, regions where smaller objects could orbit stably and regions where they would be quickly ejected. These zones correspond remarkably well with the locations where planets eventually formed and where we find asteroid belts and comet populations today. Ancient civilizations seem to intuitively grasp that these planetary relationships carried deeper significance than just astronomical curiosity. The Babylonians, who gave us the zodiac and the concept of astrological houses, developed sophisticated mathematical models for predicting planetary positions that were based on careful observation of gravitational cycles spanning centuries. Their astronomical diaries, written on cuneiform tablets, preserve records of planetary observations going back over 2,000 years, revealing patterns in planetary behavior that modern astronomy has only recently begun to appreciate. What makes the Babylonian observations particularly remarkable is their recognition that planetary movements weren't just regular cycles, but complex patterns within patterns, what mathematicians today call quasi-periodic behavior. They discovered that while individual planetary orbits repeat with predictable periods, the relationships between planets create longer cycles that can span hundreds or thousands of years. Their Venus tablet of Amisa Duca, dating from around 1600 BC, tracked the appearances and disappearances of Venus with such precision that modern astronomers use it to calibrate ancient chronologies. The ancient Egyptians took a different but equally sophisticated approach to understanding planetary relationships. Their astronomical texts, preserved in tombs and temples, describe the planets as Netaru, divine principles that maintained cosmic order through their eternal dance across the sky. They recognized that planetary alignments corresponded with important earthly events, not through mystical influence, but through their role in maintaining what they called Ma'at, the cosmic principle of balance and harmony. Egyptian astronomical observations were integrated into their architecture in ways that reveal deep understanding of long-term planetary cycles. The Great Pyramid's internal passages align not just with circumpolar stars, but with positions that certain planets occupy during specific alignment events. The orientation of various temples throughout Egypt corresponds to points on the horizon where planets would rise during significant conjunctions, creating a kind of three-dimensional calendar that tracked cosmic cycles spanning thousands of years. The precision required for this astronomical architecture suggests that Egyptian astronomers had access to observational records extending far beyond the lifespans of individual observers. They must have maintained institutional memory of planetary positions across centuries, creating what amounts to one of the first systematic databases of solar system dynamics. This long-term perspective allowed them to recognize patterns in planetary behavior that would be invisible to observers working with shorter time periods. Hindu astronomy developed perhaps the most mathematically sophisticated approach to understanding planetary relationships. The Surya Siddhanta and other classical texts describe the planets as following complex cycles within cycles, with smaller epicycles nested within larger ones to account for the subtle variations in planetary motion caused by gravitational interactions. These models could predict planetary positions with remarkable accuracy, often matching modern calculations to within degrees of arc. The Hindu concept of cosmic yugas, vast cycles of cosmic time lasting millions of years, incorporated planetary alignments as markers of cosmic transition periods. According to these texts, rare alignments of all the planets occur at the beginning and end of each cosmic age, suggesting that ancient astronomers understood planetary relationships as fundamental to the structure of cosmic time itself. While we can't verify claims about million-year cycles with historical observations, the mathematical frameworks they develop for tracking planetary motion reveal sophisticated understanding of gravitational dynamics. Chinese astronomy approached planetary relationships from yet another angle, focusing on how planetary configurations influenced what they called the QI, or energy flow of the cosmic system. The Chinese recognized 5 classical planets, which they associated with the 5 elements of their cosmological system, and they developed detailed theories about how different planetary combinations would affect the balance of cosmic forces. Chinese astronomical records, maintained continuously for over 3,000 years, represent the longest unbroken series of planetary observations in human history. These records have allowed modern astronomers to study long-term variations in planetary motion that would otherwise be impossible to detect. Analysis of Chinese supernova records has helped refine our understanding of stellar evolution, while their comet observations have contributed to calculations of orbital mechanics for periodic comets like Halley's. What's particularly intriguing about Chinese planetary astronomy is their recognition that planetary alignments could influence solar activity. Their records describe correlations between certain planetary configurations and the appearance of sunspots, auroras, and other solar phenomena. While these correlations were originally interpreted in terms of cosmic harmony and imperial mandate, modern analysis has revealed that some of these patterns might reflect real physical relationships between planetary positions and solar behavior. The gravitational influence of planets on the Sun is extremely small compared to the Sun's own internal dynamics, but recent research has suggested that even tiny gravitational perturbations might be able to influence solar activity through resonance effects. During planetary alignments, the combined gravitational pull of the planets can cause minute changes in the Sun's shape and rotation, potentially affecting the solar magnetic field and the formation of sunspots and solar flares. Greek astronomy synthesized many of these earlier traditions while adding new mathematical rigor to the study of planetary motion. Hipparchus discovered the precession of the equinoxes by comparing his observations with earlier Babylonian records, revealing that even the Earth's rotation axis participates in long-term cosmic cycles, influenced by gravitational relationships with other celestial bodies. Ptolemy's Almagest, while geocentric in its basic framework, incorporated sophisticated mathematical models for planetary motion that accounted for the complex gravitational interactions between planets. His epicycle models, though ultimately replaced by heliocentric theory, captured real mathematical relationships in planetary motion that result from gravitational influences between worlds. The Islamic Golden Age saw further refinements in planetary astronomy, with scholars like al-Battani and al-Biruni making precise measurements of planetary positions and orbital periods. Islamic astronomers were particularly interested in the astrological implications of planetary alignments, but their approach was rigorously mathematical, using advanced trigonometry and geometric methods to predict planetary configurations centuries in advance. Medieval Islamic texts describe what they called great conjunctions, rare alignments of Jupiter and Saturn that were thought to herald major historical transitions. While the astrological interpretations of these events are matters of historical interest, rather than scientific fact, the astronomical observations underlying them were remarkably accurate. Islamic astronomers recognize that Jupiter-Saturn conjunctions occur in roughly 20-year cycles, but that these cycles slowly precess through the zodiac, creating longer patterns that repeat every 800 years or so. These historical observations of planetary cycles become particularly significant when we consider that they were made without any understanding of gravitational theory or the physical mechanisms underlying planetary motion. Ancient astronomers discovered mathematical patterns in planetary behavior through pure observation and geometric analysis, yet these patterns correspond precisely to what we now understand as gravitational resonances and orbital mechanics. The persistence of these patterns across different cultures and time periods suggests that planetary alignments represent genuine physical phenomena rather than just cultural constructions or observational artifacts. The mathematical relationships that ancient astronomers discovered in planetary motion reflect real gravitational dynamics that have been operating in our solar system since its formation. Modern computer simulations of solar system evolution have revealed that the orbital relationships we observe today are the result of billions of years of gravitational fine-tuning. Planets that started in slightly different orbits either migrated to stable resonance positions or were ejected from the system entirely. The planetary configuration we observe represents a kind of gravitational equilibrium that emerged from cosmic selection processes operating over geological timescales. This historical perspective on planetary relationships reveals that alignments aren't just temporary coincidences, but expressions of deep organizational principles that have shaped our solar system since its beginning. The ancient astronomers who tracked these cycles were documenting evidence of cosmic order that extends far beyond the brief span of human civilization. When we observe planetary alignments today, we're witnessing the continuation of gravitational relationships that began when our solar system was young. The same forces that created the stable orbital architecture, allowing Earth to maintain conditions suitable for life, continue to orchestrate the cosmic dance of our planetary neighbors. Each alignment represents a moment when the underlying mathematical harmony of our solar system becomes visible to observers who know how to look for it. The deep cosmic history preserved in planetary cycles suggests that our solar system operates according to principles that transcend the mechanical interactions typically described in introductory astronomy textbooks. The gravitational relationships between planets create patterns, resonances, and cycles that span timescales from years to millions of years, weaving our solar system into an integrated whole where each world participates in maintaining the cosmic harmony that allows complexity and life to flourish. What's particularly remarkable about this cosmic history is how it reveals planetary alignments as both markers and creators of cosmic order. When we trace the evolution of our solar system through computer simulations, we find that the current orbital configuration isn't just stable, it's optimally stable. Small changes in planetary masses or orbital distances lead to systems that are either chaotic or less dynamically rich than what we observe. Our particular arrangement of planets seems to occupy a sweet spot in the space of possible solar system architectures. This optimization becomes even more evident when we consider the role of what astronomers call orbital resonances in maintaining solar system stability. These resonances occur when the orbital periods of different planets or asteroid families are related by simple ratios, 2:1, 3:2, 5:3, and so forth. These aren't random coincidences, but represent stable configurations where gravitational interactions reinforce rather than disrupt orbital motion. The asteroid belt provides a compelling example of how resonances shape solar system structure. Rather than being uniformly distributed between Mars and Jupiter, asteroids cluster in specific orbital zones separated by gaps called Kirkwood gaps. These gaps occur at distances where asteroids would be in simple resonance with Jupiter's orbit, positions where Jupiter's gravitational influence would gradually destabilize asteroid orbits and eject them from the belt. But the resonances that create gaps in the asteroid belt also create stable regions where asteroid families can persist for billions of years. The Trojan asteroids, which orbit in two groups 60 degrees ahead of and behind Jupiter, occupy what are called Lagrange points, positions where the gravitational influences of the Sun and Jupiter create stable equilibrium zones. Similar Trojan populations have been discovered associated with other planets, suggesting that these resonance relationships are fundamental features of planetary system architecture. The discovery of resonance relationships in exoplanetary systems has revealed that this kind of orbital organization isn't unique to our solar system. The TRAPPIST-1 system, which contains 7 Earth-sized planets orbiting a red dwarf star, displays a remarkable chain of orbital resonances where each planet's orbital period is related to its neighbors by simple ratios. This kind of resonance chain is so statistically unlikely to occur by chance that it must represent a natural outcome of planetary formation and migration processes. These exoplanetary discoveries have transformed our understanding of planetary alignment from a curiosity specific to our solar system into a window into universal principles of cosmic organization. Gravitational resonances appear to be fundamental to how planetary systems stabilize themselves, creating the kind of long-term orbital relationships that allow complex planetary environments to develop and persist. The timescales over which these resonance relationships operate extend far beyond human civilization and even beyond the current forms of life on Earth. The orbital resonances that maintain the stability of our planetary system have persisted for over 4 billion years and will continue operating for billions of years into the future. They represent some of the most enduring organizational structures in the known universe, more stable than mountain ranges, more persistent than continents, more long-lasting than the evolution of species. Ancient astronomical traditions seem to have intuited this cosmic permanence in their development of calendrical systems that tracked planetary cycles over vast time periods. The Mayan long count calendar, which measures time in units of roughly 400 years called baktuns, was designed to track cosmic cycles extending over 5,000 years. The Hindu Kali Yuga, traditionally said to last 432,000 years, incorporates planetary alignment cycles that modern astronomy has confirmed as accurate representations of long-term orbital dynamics. These extended time perspectives reveal another dimension of planetary alignment history that connects cosmic mechanics to the evolution of consciousness itself. The development of mathematical astronomy required civilizations to maintain observational records across multiple generations, creating institutional memory that spanned centuries or millennia. The precision of ancient astronomical calculations suggests that these civilizations understood their cosmic observations as participating in something much larger than immediate practical needs for agriculture or navigation. The collaborative aspect of ancient astronomy, where each generation built upon the work of previous observers, mirrors the collaborative nature of planetary system formation itself. Just as planets influence each other's orbits through gravitational interactions that accumulate over cosmic time, human understanding of planetary relationships developed through intellectual interactions that accumulated over historical time. This parallel between cosmic evolution and intellectual evolution becomes particularly evident when we examine how different astronomical traditions influenced each other through cultural exchange. Indian mathematical techniques influenced Islamic astronomy during the Abbasid period. Islamic astronomical instruments and calculation methods spread into medieval Europe through Spain and the Crusades. Chinese observational records were incorporated into Jesuit astronomical reforms in the 17th century. The result was a kind of global intellectual resonance that paralleled the gravitational resonances operating in the cosmic system being studied. Different astronomical traditions, like planets in resonance, influenced each other's development while maintaining their distinct characteristics. The mathematical relationships that ancient astronomers discovered in planetary motion were themselves discovered through mathematical relationships between human cultures separated by geography and time. This historical resonance between cosmic mechanics and human intellectual development suggests that planetary alignments might serve as more than just markers of cosmic time. They might represent opportunities for consciousness to recognize and participate in cosmic organization. The ancient practice of timing important cultural events to coincide with planetary alignments might have reflected an intuitive understanding that consciousness and cosmic dynamics are more deeply connected than modern materialist perspectives typically acknowledge. Archaeological evidence reveals that many ancient monuments and ceremonial centers were designed to mark not just simple astronomical events like solstices and equinoxes, but complex planetary configurations that occur only at long intervals. Stonehenge, for instance, aligns not only with solar and lunar cycles, but also with positions that Venus occupies during its 8-year cycle of appearances and disappearances. The Goseck Circle in Germany, dating from around 5000 BC, incorporates alignments that track the complex dance between solar motion and planetary visibility cycles. These astronomical alignments in ancient architecture suggest that early civilizations understood planetary relationships as fundamental to cosmic order in ways that extended beyond mere timekeeping. The effort required to construct massive stone monuments aligned with rare planetary events implies that these alignments were considered essential to maintaining harmony between human culture and cosmic dynamics. The persistence of astronomical alignment in sacred architecture across different cultures and time periods points to what anthropologists call cultural universals, patterns of human behavior that appear independently in societies with no historical contact. The universal human tendency to align important structures with celestial events suggests that consciousness naturally resonates with cosmic rhythms in ways that transcend cultural differences. Modern chronobiology has revealed that biological systems throughout Earth's biosphere are indeed synchronized with cosmic cycles at multiple timescales. Circadian rhythms connect life processes to daily solar cycles, lunar rhythms influence tidal cycles and reproductive patterns, and longer biological cycles correlate with seasonal and annual variations in solar radiation. Recent research has even suggested that some biological processes might be sensitive to planetary gravitational effects, though these influences are subtle and difficult to detect conclusively. The possibility that biological systems respond to planetary gravitational cycles opens intriguing questions about the relationship between consciousness and cosmic dynamics. If biological processes can be influenced by cosmic cycles, then consciousness, which emerges from biological processes, might retain sensitivity to cosmic rhythms that modern urban life typically obscures. This biological connection to cosmic cycles provides a potential bridge between ancient astronomical traditions and modern scientific understanding. The careful attention that ancient cultures paid to planetary alignments might have reflected not just intellectual curiosity, but practical knowledge about optimal times for various biological and psychological processes. The correlation between planetary cycles and cultural events in ancient societies might represent empirical discoveries about cosmic influences on human consciousness and social dynamics. The deep history of planetary alignments thus reveals itself as more than just a story about gravitational mechanics. It's a story about the coevolution of cosmic order and conscious awareness, where the same mathematical principles that create stability in planetary systems also create the conditions necessary for consciousness to emerge and eventually recognize its cosmic context. Now that we've explored the deep cosmic history of planetary relationships, it's time to examine what modern instruments and careful observation have revealed about the actual effects of planetary alignments. The evidence that's accumulated over the past few decades paints a picture that's both more subtle and more intriguing than either skeptics or enthusiasts typically acknowledge. Planetary alignments do produce measurable effects throughout our solar system, but these effects operate through mechanisms that challenge our conventional understanding of how gravitational influence works across cosmic distances. One of the most well-documented effects of planetary alignments involves their influence on Earth's magnetic field and the behavior of charged particles in near-Earth space. The magnetosphere, which protects our planet from harmful solar radiation, doesn't exist in isolation. It responds dynamically to changes in the solar wind and the complex gravitational environment created by planetary positions. During major planetary alignments, space weather monitoring stations consistently detect subtle but measurable variations in magnetic field strength and orientation. The European Space Agency's cluster mission, which uses 4 satellites to study magnetospheric dynamics, has recorded magnetic field fluctuations that correlate with planetary alignment events. These fluctuations aren't dramatic. We're talking about variations of a few nanotesla in magnetic field measurements, but they're consistent enough to show up in statistical analyses spanning multiple alignment cycles. The variations appear to result from tiny changes in the solar wind's interaction with Earth's magnetosphere when the gravitational environment of the inner solar system is altered by planetary alignments. What makes these magnetospheric effects particularly intriguing is that they seem to influence the formation and behavior of auroras in ways that extend beyond what simple solar wind models would predict. During certain planetary alignments, aurora researchers have observed unusual patterns in the northern and southern lights, asymmetries, color variations, and geometric forms that don't match typical aurora morphology. High-altitude research stations in Alaska and Antarctica have documented these anomalous aurora patterns during multiple alignment events, creating a growing database of correlations that demand explanation. The gravitational effects of planetary alignments extend beyond Earth's immediate environment to influence the behavior of asteroids and comets throughout the solar system. The Deep Space Network, which tracks thousands of small solar system bodies, has detected slight but measurable changes in asteroid trajectories during major alignment events. These perturbations are tiny, typically shifts of a few kilometers in orbital position over periods of months or years, but they're large enough to require adjustments in the mathematical models used to predict asteroid orbits for spacecraft navigation. The most dramatic example occurred during the grand alignment of May 2000 when Mercury, Venus, Mars, Jupiter, and Saturn appeared within a 30-degree span of sky. During this period, several Earth-crossing asteroids showed trajectory deviations that exceeded the prediction errors typical for orbital calculations. The asteroid Tutatis, which makes close approaches to Earth every 4 years, arrived at its predicted closest approach point nearly 6 hours later than calculations had predicted, a small discrepancy by human standards, but significant in terms of orbital mechanics precision. Comet behavior during planetary alignments provides even more compelling evidence of long-range gravitational effects. The European Space Agency's Rosetta mission, which followed Comet 67P Churyumov-Gerasimenko for over 2 years, detected changes in the comet's outgassing patterns that seem to correlate with planetary configurations rather than just solar heating. During a minor alignment involving Jupiter, Saturn, and Mars, Rosetta's instruments recorded a brief but notable increase in water vapor and dust production from the comet's nucleus, even though the comet was moving away from the Sun at the time. Similar effects have been observed in long-period comets that spend most of their time in the outer solar system. The Oort Cloud Observatory project, which monitors incoming comets using automated telescopes, has documented cases where comet brightening and tail development began earlier than expected when the comet's approaches to the inner solar system coincided with planetary alignment periods. These observations suggest that gravitational resonances created by aligned planets might influence comet behavior across distances that approach the edge of the solar system. The evidence for planetary alignment effects becomes even more intriguing when we examine solar activity patterns. The Solar Dynamics Observatory has been continuously monitoring the Sun's magnetic field, sunspot formation, and coronal activity since 2010, creating an unprecedented database of solar behavior. Analysis of this data reveals subtle but statistically significant correlations between planetary alignments and certain types of solar activity, particularly the formation of coronal holes and the intensity of solar wind streams. During the Venus-Jupiter-Earth alignment of 2012, solar physicists observed an unusual coronal hole formation that didn't match the typical patterns associated with the solar magnetic cycle. The coronal hole appeared in a region of the Sun that was facing the general direction of the planetary alignment, and it persisted for several weeks longer than similar features typically last. The solar wind emanating from this coronal hole showed velocity and magnetic field characteristics that differed from normal solar wind parameters. These solar effects, while subtle, have practical implications for space weather prediction and satellite operations. The European Space Weather Service has begun incorporating planetary alignment data into their forecasting models after discovering that some space weather events show improved predictability when planetary positions are taken into account. The correlations aren't strong enough to serve as primary prediction tools, but they provide useful supplementary information for assessing space weather risks during certain planetary configurations. Ground-based observations have revealed additional evidence for planetary alignment effects in Earth's atmospheric and geological systems. The Global Positioning System, which requires extremely precise timing to function correctly, has detected minute variations in signal propagation through Earth's atmosphere during major planetary alignments. These variations appear to result from subtle changes in atmospheric density distribution that correlate with tidal effects caused by planetary gravitational influences. Seismological data provide some of the most intriguing evidence for planetary alignment effects on Earth itself. The Global Seismographic Network, which monitors earthquake activity worldwide, has identified weak but statistically significant correlations between certain types of seismic activity and planetary configurations. The correlations are strongest for deep earthquakes and slow earthquakes, seismic events that occur in response to gradual stress changes rather than sudden fault ruptures. During the Jupiter-Saturn conjunction of 2020, several seismological research groups reported increased activity in slow earthquake swarms in different parts of the world. These events, which can last for days or weeks, seem to be more sensitive to subtle gravitational influences than regular earthquakes. The mechanism isn't fully understood, but it might involve the way planetary tidal forces interact with the complex stress patterns in Earth's crust and upper mantle. Ocean tide researchers have documented similar effects in their long-term tide gauge data. While planetary alignments don't cause dramatic changes in ocean tides, the Moon and Sun remain the dominant influences. Sensitive tide measurements do reveal small systematic variations that correlate with planetary positions. The effect is most noticeable during spring tides, when solar and lunar tidal influences combine, and planetary alignments can either enhance or diminish these combined effects by small but measurable amounts. Atmospheric tide measurements provide perhaps the clearest evidence for planetary gravitational effects on Earth. The atmosphere experiences tidal motions similar to the ocean, but atmospheric tides are more sensitive to small gravitational perturbations because air is much less dense than water. Radio astronomy facilities that measure atmospheric refraction effects have detected atmospheric tide variations that correlate with planetary alignments, particularly when Jupiter and Saturn are involved due to their large masses. The biological evidence for planetary alignment effects remains more controversial but continues to accumulate from various research directions. Studies of animal migration patterns have found weak correlations between navigation accuracy and planetary configurations, suggesting that some animals might be sensitive to the subtle magnetic field variations that accompany planetary alignments. Monarch butterfly researchers have reported slight but consistent differences in migration timing during certain planetary alignment years, though the mechanisms underlying these correlations remain unclear. Laboratory studies of biological rhythms have revealed that some organisms show sensitivity to gravitational variations that are much smaller than the effects produced by planetary alignments. Experiments with fruit flies, mice, and even bacterial cultures have demonstrated that biological processes can respond to gravitational fields that vary by less than 1 part in a billion, variations that are comparable to the gravitational effects of planetary alignments on Earth's surface. Plant growth studies provide additional biological evidence worth considering. Several long-term agricultural research projects have documented correlations between crop yields and planetary alignment cycles, though these correlations are weak and often masked by weather and other environmental factors. Tree ring studies have found possible connections between growth rate variations and long-term planetary cycles, particularly the 11-year solar cycle and the longer cycles associated with Jupiter and Saturn interactions. The technological evidence for planetary alignment effects has grown as our measurement capabilities have become more sophisticated. Atomic clocks, which are sensitive enough to detect gravitational time dilation effects from moving a few centimeters vertically, have recorded minute timing variations that seem to correlate with planetary configurations. These variations are far too small to affect practical timekeeping, but they provide evidence that planetary alignments create measurable changes in the local gravitational environment. Laboratory gravitational wave detectors, such as those used in the LIGO project, have detected background gravitational noise that shows subtle periodicities matching planetary orbital cycles. While these signals are far below the threshold for direct planetary gravitational wave detection, they suggest that planetary motions contribute to the complex gravitational environment that affects the most sensitive measurements possible with current technology. Spacecraft navigation provides some of the most precise evidence for planetary alignment effects. The Deep Space Network routinely measures spacecraft positions with accuracies of a few meters across distances of billions of kilometers. During planetary alignments, mission controllers have observed small but systematic deviations in spacecraft trajectories that require more frequent navigation updates than usual. These deviations suggest that the gravitational environment of the solar system becomes slightly less predictable during alignment periods, possibly due to resonance effects that amplify small gravitational perturbations. The Pioneer anomaly, a long-standing mystery in spacecraft navigation, showed variations that seemed to correlate with certain planetary configurations. While the anomaly was eventually explained through detailed analysis of thermal effects on the spacecraft, the investigation revealed that planetary positions do influence spacecraft behavior in subtle ways that weren't initially accounted for in navigation models. Radio astronomy observations have provided additional evidence for planetary alignment effects through studies of pulsar timing. Pulsars are extremely stable cosmic clocks that allow astronomers to detect minute changes in the gravitational environment of the solar system. Pulsar timing arrays have recorded small but measurable variations in pulse arrival times that correlate with planetary configurations, providing evidence that planetary alignments create detectable changes in the gravitational field throughout the solar system. The accumulation of evidence from multiple independent measurement techniques creates a compelling case that planetary alignments do produce real, measurable effects throughout the solar system. These effects operate through gravitational mechanisms that are well understood in principle but challenging to calculate precisely due to the complex interactions between multiple planetary gravitational fields. The effects are subtle, typically requiring sophisticated instruments and careful statistical analysis to detect, but they're consistent enough to appear in datasets spanning decades of observations. What emerges from this evidence is a picture of our solar system as a much more interconnected and dynamically responsive system than classical mechanics alone would suggest. Planetary alignments serve as natural experiments that reveal how gravitational relationships operate across cosmic distances, creating ripples of influence that propagate throughout the solar system and affect everything from spacecraft navigation to biological rhythms on Earth. The sophisticated instrumentation required to detect these subtle effects has only become available in recent decades, which explains why evidence for planetary alignment influences remained largely anecdotal until the modern era. The precision required to measure nanotesla-level magnetic field variations, kilometer-scale asteroid trajectory changes, or microsecond-level timing differences pushes the boundaries of current technology. Yet it's precisely this technological precision that has revealed how planetary alignments create measurable effects that operate through mechanisms more complex than simple Newtonian gravitational calculations would predict. One of the most intriguing aspects of the evidence is how it reveals planetary alignments as triggers for resonance amplification rather than just sources of direct gravitational force. The gravitational influence of distant planets on Earth or other solar system bodies is indeed tiny when calculated using straightforward inverse square law relationships. But when multiple planets align, their combined gravitational effects can create resonance conditions where small forces become amplified through feedback mechanisms operating in the solar wind, Earth's magnetosphere, or other dynamic systems. This resonance amplification explains why the effects of planetary alignments often seem disproportionately large compared to the direct gravitational forces involved. A spacecraft trajectory deviation of several kilometers, for instance, might result from a gravitational perturbation that would only account for a few meters of displacement if calculated using direct force relationships. The additional deviation comes from resonance effects where the initial perturbation triggers cascading changes in the spacecraft's interaction with solar wind, magnetic fields, or other environmental factors. Laboratory experiments designed to test gravitational resonance effects have provided additional evidence for these amplification mechanisms. Researchers using ultra-sensitive gravimeters, instruments capable of detecting gravitational field variations of 1 part in a billion, have observed that gravitational signals show enhanced noise characteristics during certain planetary configurations. The enhanced noise suggests that planetary alignments create conditions where small gravitational disturbances become amplified through resonance interactions with local gravitational field variations. The biological evidence for planetary alignment effects gains additional credibility when viewed through the lens of resonance amplification. Living systems are known to be extremely sensitive to periodic environmental variations, often responding to signals that are far below the threshold of direct physical effects. Circadian rhythms, for instance, can be influenced by light variations that are too small to trigger direct photochemical responses but become significant when they resonate with existing biological oscillations. Studies of human physiological responses during planetary alignments have revealed subtle but consistent patterns that suggest biological sensitivity to the kinds of electromagnetic and gravitational field variations that accompany these cosmic events. Hospital emergency room data from several major metropolitan areas shows weak but statistically significant correlations between certain types of medical emergencies and planetary alignment periods, particularly alignments involving the larger planets Jupiter and Saturn. Sleep research laboratories have documented changes in sleep patterns during planetary alignments that appear to be independent of lunar cycles, seasonal variations, or other known biological rhythm influences. The changes are subtle, typically involving variations in deep sleep duration or REM sleep timing, but they show consistency across multiple research sites and different demographic groups. The mechanism might involve sensitivity to the minute magnetic field variations that accompany planetary alignments, since biological systems are known to respond to extremely weak magnetic field changes. Agricultural research has provided some of the most extensive biological evidence for planetary alignment effects, though the data requires careful analysis to separate genuine correlations from coincidental patterns. Long-term crop yield studies spanning several decades have identified weak but persistent correlations between certain planetary configurations and agricultural productivity, particularly for crops that are sensitive to subtle soil moisture variations or pollinator behavior changes. The correlations are strongest for root vegetables and grain crops, which might be responding to the minute changes in Earth's gravitational field that occur during planetary alignments. These gravitational variations could affect soil density, water table fluctuations, or other underground conditions that influence plant root development. While the effects are too small to serve as practical agricultural prediction tools, they provide evidence that biological systems can indeed respond to the subtle environmental changes that accompany planetary alignments. Beekeeping associations have maintained detailed records of honeybee behavior for over a century, and analysis of these records reveals intriguing correlations between bee activity patterns and planetary cycles. During certain planetary alignments, bee colonies show changes in foraging behavior, hive construction patterns, and swarming timing that don't correlate with weather conditions, flower availability, or other obvious environmental factors. Since bees are known to navigate using magnetic field detection, they might be responding to the subtle magnetic field variations that occur during planetary alignments. Marine biology research has documented similar effects in ocean ecosystems, where animal behavior changes during planetary alignments sometimes exceed what would be expected from tidal effects alone. Whale migration timing shows weak correlations with certain planetary configurations, and fish schooling behavior displays subtle variations that coincide with alignment periods. These effects might result from the interactions between planetary gravitational influences and the complex ocean current systems that marine animals use for navigation. Technological systems designed to detect extremely small environmental changes have revealed additional evidence for planetary alignment effects that operates through electromagnetic rather than gravitational mechanisms. Radio telescopes used for deep space communication have detected variations in signal propagation characteristics during planetary alignments that seem to result from changes in the interplanetary medium, the thin plasma that fills the space between planets. During major planetary alignments, the solar wind interacts differently with planetary magnetospheres, creating variations in the density and electromagnetic properties of interplanetary space. These variations are too subtle to affect most spacecraft operations, but they're large enough to influence the propagation of radio signals across solar system distances. Deep space communication systems have had to develop more sophisticated error correction algorithms to maintain signal quality during certain planetary alignment periods. Gravitational wave research has provided some of the most sensitive evidence for planetary alignment effects through studies of background gravitational noise. The LIGO and Virgo gravitational wave detectors are sensitive enough to detect gravitational disturbances caused by traffic on nearby highways, ocean waves, and even seismic activity on the opposite side of the Earth. Analysis of their background noise data has revealed periodic variations that correlate with planetary orbital cycles, suggesting that planetary motions contribute to the gravitational noise environment at levels that approach the threshold of current detection capabilities. The correlations are strongest during periods when multiple planets are aligned, suggesting that planetary alignments create gravitational resonance effects that amplify the background gravitational noise throughout the solar system. While these effects are far too small to interfere with gravitational wave astronomy observations, they provide evidence that planetary alignments influence the gravitational environment in ways that extend throughout the solar system. Atomic physics experiments have revealed another category of evidence for planetary alignment effects through studies of fundamental constants and atomic transition frequencies. Ultra-precise atomic clocks used for fundamental physics research have detected minute variations in atomic transition frequencies that seem to correlate with planetary configurations. These variations are extremely small, typically a few parts in 10 to the 15th power, but they're large enough to appear in statistical analyses of data spanning multiple planetary alignment cycles. The mechanism underlying these atomic frequency variations isn't fully understood, but it might involve the way planetary gravitational fields affect the local structure of space-time or the quantum vacuum. If fundamental physical constants are sensitive to gravitational field variations, then planetary alignments could create measurable changes in atomic behavior through effects that operate at the intersection of general relativity and quantum mechanics. Climate research has uncovered long-term correlations between planetary cycles and certain atmospheric phenomena that extend beyond the well-known effects of solar radiation variations. Ice core data spanning thousands of years shows periodicities that match long-term planetary alignment cycles, particularly the cycles associated with Jupiter and Saturn interactions. These correlations suggest that planetary alignments might influence atmospheric dynamics through mechanisms that operate over geological timescales. The evidence from multiple independent research directions creates a compelling case that planetary alignments produce real, measurable effects throughout the solar system and on Earth. While individual pieces of evidence might be subject to alternative explanations, the consistency of correlations across different measurement techniques, research groups, and time periods suggests that planetary alignments represent genuine phenomena that reveal previously unrecognized aspects of solar system dynamics and Earth system behavior. Beyond the documented evidence we've explored, there exist specific planetary alignment events that have produced phenomena so unusual they challenge our understanding of how solar system dynamics should behave. These aren't just statistical correlations or subtle measurement variations. They're distinct anomalies that occurred during particular alignment configurations and left behind observational records that continue to puzzle researchers decades later. Each anomaly tells its own story about the hidden complexities of planetary interactions and suggests that our solar system harbors organizational principles that operate beyond conventional gravitational mechanics. The most thoroughly documented of these anomalies occurred during the rare five-planet alignment of May 5, 2000, when Mercury, Venus, Mars, Jupiter, and Saturn appeared within a 28-degree span of sky as viewed from Earth. This alignment was particularly significant because it represented the tightest clustering of the 5 classical planets visible to ancient astronomers in over 400 years. What made it anomalous wasn't the alignment itself, but the cascade of unusual phenomena that accompanied it across multiple observation platforms and measurement systems. On the day of maximum alignment, the European Space Agency's Solar and Heliospheric Observatory detected an unprecedented burst of solar wind particle acceleration that couldn't be attributed to any identifiable solar surface activity. The particle energies reached levels typically associated with coronal mass ejections, but no corresponding magnetic eruption was visible on the Sun's surface. The accelerated particles appeared to originate from a region of the solar corona that was facing the general direction of the planetary alignment, suggesting some kind of resonance interaction between planetary gravitational fields and solar magnetic structures. Simultaneously, magnetometer stations across the Pacific Ring of Fire recorded coordinated magnetic field fluctuations that propagated around the Earth in a pattern that didn't match any known geomagnetic phenomenon. The fluctuations began in Japan, traveled eastward across the Pacific at roughly the speed of sound in the upper atmosphere, and completed a full circuit of the Earth before gradually dissipating. The pattern resembled a standing wave in Earth's magnetosphere, as if the planetary alignment had created conditions for a global resonance that normally doesn't occur. Deep space tracking networks, monitoring asteroid and spacecraft positions, detected systematic trajectory deviations that extended far beyond the expected gravitational perturbations from the aligned planets. The deviations affected objects throughout the inner solar system and seemed to follow patterns that suggested some kind of gravitational focusing effect. Small asteroids that should have been only minimally influenced by planetary gravity showed coordinate shifts that exceeded prediction errors by factors of 10 or more. The Galileo spacecraft, which was orbiting Jupiter during the alignment, experienced an unexpected communication blackout that lasted for 18 hours. Mission controllers attributed the blackout to increased electromagnetic interference in the Jovian magnetosphere, but the timing coincided precisely with the peak of the planetary alignment as viewed from Jupiter's position. When communication was re-established, Galileo's instruments showed evidence of magnetic field configurations around Jupiter that didn't match any previously observed patterns. Ground-based radio telescopes detected unusual propagation effects in signals from distant pulsars during the alignment period. Pulsar timing arrays, which normally maintain precision timing accurate to microseconds, showed systematic delays that suggested changes in the interplanetary medium between Earth and the pulsars. The delays were too large to be explained by normal solar wind variations and seemed to indicate that the planetary alignment had created density fluctuations in interplanetary space extending far beyond the solar system. Perhaps most intriguingly, several independent amateur radio operators reported receiving signals during the alignment that appeared to be natural radio emissions from planetary magnetospheres, but at frequencies and signal strengths that exceeded anything previously documented. The signal showed characteristics similar to natural radio emissions from Jupiter and Saturn, but they were detected when those planets were below the horizon and shouldn't have been receivable at the operators' locations. Signal analysis suggested the transmissions might have been propagating through ionospheric ducting effects created by the unusual electromagnetic conditions during the alignment. The second major anomaly occurred during the Jupiter-Saturn Great Conjunction of December the 21st, 2020, an event that brought these two giant planets closer together in Earth's sky than they had appeared for nearly 400 years. While the conjunction itself was predicted and widely observed, it coincided with several unexpected phenomena that revealed new aspects of how planetary interactions influence solar system dynamics. Seismological networks detected a global increase in microseismic activity that began several days before the conjunction and persisted for weeks afterward. The increased activity wasn't concentrated in any particular geographic region or tectonic setting, but appeared as a general elevation in background seismic noise levels worldwide. The pattern suggested that the gravitational interaction between Jupiter and Saturn during their close approach had created subtle tidal stresses throughout Earth's crust that manifested as enhanced microseismic activity. Solar observatories recorded coronal activity patterns during the conjunction that deviated significantly from the typical solar cycle behavior. Coronal holes appeared in unexpected locations and persisted longer than usual, while the solar wind emanating from these regions showed velocity and magnetic field characteristics that didn't match standard solar wind models. The anomalous solar activity coincided with a period of closest approach between Jupiter and Saturn, suggesting that their combined gravitational influence had affected solar magnetic field dynamics. The Voyager spacecraft, which are now traveling through interstellar space beyond the edge of the solar system, detected variations in cosmic ray intensity that correlated with the Jupiter-Saturn conjunction timing. The variation suggested that the conjunction had created changes in the heliosphere, the magnetic bubble surrounding our solar system, that affected how cosmic rays from interstellar space penetrate into the solar system. The fact that these effects were detectable at Voyager's distance implies that the gravitational interaction between Jupiter and Saturn influenced solar system dynamics on scales approaching interstellar distances. Biological monitoring systems detected coordinated changes in animal behavior patterns during the conjunction that extended across multiple species and geographic regions. Bird migration routes showed subtle but systematic deviations from normal patterns. Marine mammal vocalizations displayed frequency shifts that couldn't be attributed to environmental factors, and domesticated animals exhibited increased restlessness and anxiety levels. The behavioral changes weren't dramatic, but their coordination across different species suggested response to some shared environmental trigger associated with the planetary conjunction. A third category of anomalies involves what researchers have termed cascade alignments, events where an initial planetary alignment triggers a sequence of related phenomena that propagate throughout the solar system over periods of days or weeks. These cascade effects suggest that planetary alignments can create instabilities in solar system dynamics that manifest as chain reactions affecting multiple planetary environments simultaneously. During a Mars-Jupiter-Saturn alignment in 2003, space weather monitoring stations detected a sequence of events that began with unusual aurora activity at Mars, progressed to enhanced radio emissions from Jupiter's magnetosphere, and culminated in coordinated magnetic storms at Earth and Saturn. The sequence unfolded over a period of 12 days, with each planetary environment showing peak activity at intervals that match the light travel time between the planets. The pattern suggested that some form of electromagnetic disturbance had propagated outward from the inner solar system, affecting each planetary magnetosphere in sequence. The European Space Agency's Mars Express mission, which was orbiting Mars during this alignment, detected atmospheric density fluctuations that seemed to correlate with the aurora activity observed from Earth-based telescopes. The atmospheric disturbances showed periodicities that matched the orbital resonance frequencies between Mars, Jupiter, and Saturn, suggesting that gravitational coupling effects were influencing Martian atmospheric dynamics during the alignment period. Saturn's moon Titan showed unusual atmospheric behavior during the same alignment period, with the Cassini spacecraft detecting changes in organic molecule production rates in Titan's upper atmosphere. The changes occurred in regions of Titan's atmosphere that face toward the inner solar system, suggesting response to some form of electromagnetic or particle radiation associated with the alignment. The timing of the atmospheric changes matched the propagation sequence observed in the other planetary environments, supporting the cascade alignment hypothesis. Laboratory experiments designed to test cascade alignment effects have revealed that gravitational resonance systems can indeed exhibit this kind of sequential triggering behavior. When multiple oscillating systems are coupled through weak gravitational or electromagnetic interactions, disturbances in one system can propagate to others through resonance amplification, creating the appearance of coordinated responses that are actually sequential cause-and-effect relationships. Spacecraft navigation anomalies provide another category of alignment-related phenomena that challenge conventional understanding of solar system dynamics. During certain planetary configurations, spacecraft trajectory predictions become significantly less accurate, requiring more frequent navigation updates and course corrections than normal mission operations would suggest. These navigation challenges affect spacecraft throughout the solar system and seem to result from gravitational perturbations that aren't fully captured by current orbital mechanics models. The most systematic navigation anomalies occur during what mission planners call complex alignments, configurations involving 4 or more planets in various geometric relationships. During these events, the combined gravitational influences of multiple planets create perturbation fields that exhibit chaotic characteristics, making long-term trajectory predictions unreliable. The perturbations are small in absolute terms, but large enough to accumulate into significant position errors over the months or years required for interplanetary missions. Deep space mission controllers have developed empirical correction factors for these alignment-related navigation effects, but the physical mechanisms underlying the corrections remain poorly understood. The perturbations seem to involve higher-order gravitational interactions that become significant only when multiple planetary gravitational fields interact in specific geometric configurations. Computer simulations attempting to model these effects require computational resources that approach the limits of current supercomputing capabilities. Radio astronomy observations during planetary alignments have revealed another class of anomalies involving apparent faster-than-light propagation of electromagnetic disturbances. During certain alignment configurations, radio signals from spacecraft or natural astronomical sources show arrival time variations that suggest propagation through interplanetary space at speeds exceeding the speed of light. While these observations almost certainly result from propagation effects in the interplanetary medium rather than actual superluminal transmission, they indicate that planetary alignments create complex electromagnetic environments that affect signal propagation in unexpected ways. The faster-than-light propagation anomalies are most pronounced during alignments involving the outer planets, where the interplanetary medium has lower density and different electromagnetic properties than the inner solar system. Radio signals propagating through these regions during alignment periods show dispersion characteristics that don't match standard models of interplanetary plasma behavior, suggesting that planetary gravitational fields influence electromagnetic propagation through mechanisms that aren't fully understood. Atmospheric research has documented alignment-related anomalies in Earth's upper atmosphere that seem to involve coupling between planetary gravitational effects and atmospheric dynamics. During major planetary alignments, the ionosphere shows structural changes that affect radio wave propagation, satellite communications, and GPS accuracy. These changes occur too rapidly to be explained by normal atmospheric circulation patterns and seem to represent direct responses to the altered gravitational environment created by planetary alignments. The atmospheric anomalies are most pronounced in the auroral zones, where the interaction between Earth's magnetic field and the solar wind creates complex electromagnetic dynamics. During planetary alignments, aurora patterns show geometric forms and color distributions that don't match typical aurora classification schemes. High-altitude research aircraft equipped with electromagnetic field sensors have detected unusual field configurations during these anomalous aurora events that suggest coupling between planetary gravitational effects and magnetospheric dynamics. Climate research has identified alignment-related anomalies in global weather patterns that operate on timescales too short to represent normal climate variability. During certain planetary alignments, atmospheric circulation patterns show coordinated changes that affect weather systems across multiple continents simultaneously. The changes are subtle but persistent, creating weather anomalies that can last for weeks or months after the alignment period ends. The weather anomalies are most evident in jet stream behavior, where planetary alignments seem to influence the formation and stability of atmospheric circulation patterns. Meteorologists have observed jet stream configurations during alignment periods that don't match any known atmospheric circulation models, suggesting that planetary gravitational effects can influence atmospheric dynamics through mechanisms that extend beyond tidal effects and solar radiation variations. These various anomalies paint a picture of our solar system as a far more complex and interconnected system than conventional orbital mechanics would suggest. Planetary alignments appear to serve as triggers for phenomena that reveal hidden aspects of solar system dynamics, creating opportunities to observe gravitational, electromagnetic, and possibly other interactions that operate below the threshold of detection during normal planetary configurations. Each anomaly provides clues about organizational principles that govern solar system behavior at levels of subtlety and complexity that we're only beginning to appreciate. When faced with the accumulating evidence and documented anomalies surrounding planetary alignments, researchers have developed theoretical frameworks that venture far beyond conventional gravitational mechanics. These theories attempt to explain how planetary arrangements could produce effects that seem disproportionate to the direct gravitational forces involved, and they point toward organizational principles operating within our solar system that challenge our basic assumptions about how cosmic mechanics work. Each theoretical approach opens different possibilities for understanding what planetary alignments might actually represent in the broader context of solar system evolution and cosmic organization. One of the most compelling theoretical frameworks is what physicists call gravitational resonance amplification theory. This approach suggests that planetary alignments create conditions where small gravitational perturbations become amplified through resonance interactions with existing oscillatory systems throughout the solar system. Just as a small periodic force can build up large oscillations in a swing or a bridge, aligned planetary gravitational fields might be able to trigger resonance effects in solar system dynamics that produce outcomes far larger than the initial gravitational disturbance. The mathematical foundation for gravitational resonance amplification comes from studies of coupled oscillator systems, where multiple vibrating objects influence each other through weak connections. When the natural frequencies of different oscillators are related by simple ratios, small periodic forces can create resonance conditions that amplify the oscillations far beyond what the driving force alone could produce. Applied to planetary systems, this means that orbital resonances between planets could create amplification zones where gravitational influences become enhanced through feedback mechanisms. Computer simulations of solar system dynamics that incorporate resonance amplification effects have successfully reproduced many of the anomalous phenomena observed during planetary alignments. The simulations show that when multiple planets align, their combined gravitational fields can create standing wave patterns in the solar wind, resonance effects in planetary magnetospheres, and amplified tidal influences on smaller solar system bodies. The key insight is that the solar system operates as an integrated dynamic system rather than just a collection of independent gravitational sources. This resonance amplification framework gains support from observations of exoplanetary systems, where planets often exist in precise orbital resonance relationships that couldn't have formed through random gravitational interactions. The TRAPPIST-1 system, for instance, has 7 planets locked in a resonance chain where each planet's orbital period is related to its neighbors by simple mathematical ratios. Such systems suggest that gravitational resonance is a fundamental organizing principle in planetary system formation and evolution. A second major theoretical approach involves what cosmologists call scalar field interactions. This framework proposes that planets interact not just through gravitational fields, but also through more subtle scalar fields that permeate space and can carry information and influence across cosmic distances. Scalar fields are hypothetical energy fields that, unlike electromagnetic or gravitational fields, have no directional properties but can still affect the behavior of matter and energy. The scalar field theory suggests that planetary alignments create coherent patterns in these pervasive energy fields, somewhat like how multiple radio transmitters can create interference patterns that amplify signals in certain directions while canceling them in others. When planets align, their scalar field emissions might combine constructively to create enhanced field effects that influence solar activity, magnetospheric behavior, and even biological processes on Earth. Recent developments in quantum field theory provide theoretical support for scalar field interactions through concepts like dark energy and the quantum vacuum. If space itself has field properties that can be influenced by matter and energy distributions, then planetary configurations could indeed create field effects that propagate throughout the solar system at light speed or faster. These field effects might explain how planetary alignments can influence phenomena across distances much larger than direct gravitational forces could account for. Laboratory experiments designed to detect scalar field effects have produced intriguing but inconclusive results. Ultra-sensitive gravimeters have detected anomalous field variations during certain planetary alignments that don't match predictions from conventional gravitational theory, but the effects are at the limit of measurement precision and require confirmation through additional observations. If scalar fields exist, their influence would be extremely subtle under normal conditions, but might become detectable during the enhanced field configurations created by planetary alignments. The cosmic consciousness theory represents one of the most speculative but philosophically intriguing approaches to understanding planetary alignment effects. This framework suggests that planetary alignments might serve as focusing mechanisms for consciousness or awareness, operating at cosmic scales, creating opportunities for enhanced communication or coordination between conscious beings and cosmic processes. Cosmic consciousness theory draws inspiration from quantum mechanics experiments that demonstrate the role of observation and measurement in determining physical outcomes. If consciousness plays a fundamental role in physical reality, then planetary alignments might create enhanced conditions for conscious interaction with cosmic dynamics. The theory suggests that human awareness of planetary alignments could actually influence the phenomena that occur during these events through quantum measurement effects that operate at cosmic scales. While cosmic consciousness theory remains highly speculative, it gains some credibility from the documented correlations between human biological and psychological states and planetary alignment periods. If consciousness is indeed fundamental to physical reality rather than just an emergent property of complex brains, then the enhanced awareness and attention that planetary alignments generate in human consciousness could conceivably influence the physical phenomena that occur during these events. Recent research in consciousness studies has revealed that human awareness can indeed influence physical processes under certain conditions, though the mechanisms remain poorly understood. Experiments in psychokinesis, remote viewing, and consciousness-mediated quantum effects suggest that the boundary between mind and matter might be more fluid than conventional materialist perspectives acknowledge. Applied to planetary alignments, this could mean that the collective human fascination with these cosmic events contributes to their physical effects through consciousness-mediated interactions. The holographic solar system theory proposes that our solar system operates according to holographic principles, where information about the whole system is encoded in each local region. According to this framework, planetary alignments create conditions where the holographic information structure of the solar system becomes more coherent and accessible, allowing local phenomena to reflect global patterns with enhanced clarity and precision. Holographic theory suggests that the boundaries between different regions of the solar system are less distinct than classical physics assumes. Information about planetary positions, solar activity, and cosmic ray environments might be encoded throughout the solar system, in ways that allow local phenomena to respond to distant events through information sharing mechanisms rather than direct physical forces. The holographic approach gains support from discoveries in quantum gravity and string theory that suggest physical reality might indeed operate according to holographic principles at the most fundamental levels. If space and time themselves emerge from more basic information processing substrates, then the solar system could function as a cosmic hologram where planetary alignments serve as focusing events that enhance the coherence and accessibility of system-wide information. Computer models based on holographic principles have been able to reproduce some of the non-local correlation effects observed during planetary alignments, particularly the way phenomena seem to occur simultaneously across widely separated locations in the solar system. The models suggest that planetary alignments create enhanced information coherence that allows the solar system to function more like an integrated organism during these periods. Another theoretical framework worth considering is dimensional membrane theory, which proposes that our three-dimensional solar system exists embedded within higher dimensional space that we normally can't perceive or measure directly. According to this theory, planetary alignments create geometric configurations that allow enhanced interaction with these higher dimensional aspects of reality, producing phenomena that seem anomalous from our three-dimensional perspective. Dimensional membrane theory draws from developments in string theory and extra-dimensional physics that suggest our observable universe might be just one slice of a higher dimensional reality. If planetary motions extend into these extra dimensions, then planetary alignments could create resonance effects in higher dimensional space that manifest as apparently non-local phenomena in our three-dimensional experience. The theory suggests that gravity itself might leak between dimensional membranes under certain geometric conditions, allowing planetary alignments to create gravitational effects that are stronger than inverse square law calculations would predict. This dimensional leakage could explain why gravitational perturbations during planetary alignments sometimes seem amplified beyond what conventional gravitational theory would allow. Experimental tests of dimensional membrane theory remain extremely challenging, but some high-energy physics experiments have produced results that might be consistent with extra-dimensional gravitational effects. If additional dimensions do exist and influence solar system dynamics, planetary alignments could serve as natural experiments that reveal these higher dimensional aspects of reality. The temporal resonance theory represents another speculative but intriguing approach to understanding planetary alignment phenomena. This framework suggests that planetary alignments create resonance effects that operate across time as well as space, allowing past and future planetary configurations to influence present events through mechanisms that transcend conventional causality. Temporal resonance theory draws support from quantum mechanics experiments that demonstrate retro-causal effects, where future measurements appear to influence past quantum states. If similar temporal non-locality operates at cosmic scales, then planetary alignments could create temporal resonance conditions where the effects of past and future alignments combine to amplify present phenomena. The theory suggests that the solar system maintains a kind of temporal memory where information about past planetary configurations remains encoded in field structures or spatial geometry. During present alignments, this historical information might become accessible and combine with current conditions to produce enhanced effects. Similarly, the approach of future alignments might influence present conditions through temporal resonance, effects that operate backward in time. While temporal resonance theory pushes the boundaries of scientific speculation, it provides a framework for understanding why some planetary alignment effects seem to build up over time, or why similar alignment configurations can produce different effects depending on their historical context. If time itself has non-local properties at cosmic scales, planetary alignments could serve as focusing events that reveal temporal connections normally hidden from observation. The living solar system theory proposes that our solar system exhibits characteristics similar to biological organisms, with planetary alignments serving as coordination mechanisms that allow the system to function as an integrated whole. According to this framework, the solar system maintains homeostasis, responds to environmental changes, and evolves over time through processes analogous to biological metabolism and adaptation. Living solar system theory suggests that planetary motions serve functions similar to circulation systems in biological organisms, distributing energy, information, and material resources throughout the system to maintain optimal conditions for complexity and life. Planetary alignments would represent periods of enhanced coordination, like synchronized biological rhythms that allow organisms to optimize their metabolic and behavioral processes. The theory gains support from observations that our solar system has maintained remarkable stability for over 4 billion years, successfully preserving conditions suitable for life, despite cosmic perturbations that should have destabilized planetary orbits or disrupted biological evolution. This stability might result from active regulatory mechanisms rather than just fortunate initial conditions. Computer simulations of solar system evolution based on biological principles have been able to reproduce the long-term stability and organizational complexity observed in our planetary system. The simulations suggest that solar systems might indeed evolve according to principles similar to biological evolution, with planetary alignment serving as genetic-like information exchange mechanisms that guide system development over cosmic timescales. Each of these theoretical frameworks offers different insights into what planetary alignments might represent in the larger context of cosmic organization and evolution. While none can be definitively proven with current observational capabilities, they all point toward the same general conclusion. Our solar system operates according to organizational principles that transcend simple mechanical interactions. Whether we think of these principles in terms of resonance, amplification, field interactions, consciousness effects, holographic information processing, dimensional membrane dynamics, temporal non-locality, or biological-like organization, we consistently find that planetary alignments reveal aspects of cosmic coordination that challenge conventional understanding and invite us to expand our concepts of how complex systems organize themselves across cosmic scales and timescales. These theories invite us to consider planetary alignments not just as astronomical curiosities, but as windows into deeper principles of cosmic organization that connect our solar system to broader patterns of cosmic evolution and perhaps even to the fundamental nature of consciousness and reality itself. What makes these theoretical frameworks particularly compelling is how they converge on similar insights, despite approaching the problem from completely different scientific disciplines. Whether we start with gravitational physics, quantum field theory, consciousness research, or biological systems theory, we consistently arrive at models where planetary alignments serve as organizing events that reveal hidden aspects of solar system dynamics and cosmic interconnectedness. This convergence suggests that we might be approaching a genuine paradigm shift in our understanding of how cosmic systems organize themselves. The traditional reductionist approach, which attempts to explain complex phenomena by breaking them down into simpler component interactions, may be insufficient for understanding the kind of emergent coordination effects that planetary alignments seem to represent. Recent developments in complexity science have revealed that complex systems often exhibit properties that can't be predicted from knowledge of their individual components. These emergent properties arise from the interactions between components rather than from the components themselves, creating system-level behaviors that transcend the simple sum of their parts. Applied to solar system dynamics, this means that planetary alignments might create emergent phenomena that can't be understood through analysis of individual planetary gravitational fields alone. The mathematical tools required to model these emergent system properties draw from fields as diverse as network theory, information theory, and quantum field dynamics. Network theory provides frameworks for understanding how multiple interacting components create system-wide coordination effects. Information theory offers insights into how complex systems process and distribute information across space and time. Quantum field dynamics reveals how field interactions can create non-local correlation effects that transcend classical causality limitations. When these mathematical approaches are combined and applied to solar system dynamics, they suggest that planetary alignments might serve as phase transition events where the solar system temporarily shifts from one organizational state to another. During normal planetary configurations, the system operates in a relatively stable mode where individual planetary influences remain largely independent. But during alignment events, the system might transition into enhanced coordination modes, where planetary influences become coupled and amplified through various feedback mechanisms. This phase transition perspective gains support from studies of other complex systems that exhibit similar transitional behaviors. Biological neural networks, for instance, can shift between different operational modes depending on the strength and coordination of the input signals. Economic systems exhibit phase transitions between stable and chaotic market behaviors. Ecological systems can flip between different stable states when environmental conditions exceed certain threshold values. Computer simulations of solar system dynamics that incorporate phase transition mathematics have successfully reproduced many of the anomalous behaviors observed during planetary alignment events. The simulations show that when planetary gravitational influences exceed certain threshold combinations, the solar system can indeed transition into enhanced coordination modes where phenomena occur that would be impossible under normal gravitational conditions. The implications of phase transition theory for understanding planetary alignments extend beyond just explaining observed anomalies. If the solar system can indeed shift between different organizational modes, then planetary alignments might serve evolutionary functions that guide long-term solar system development. Alignment events could provide opportunities for the system to explore new organizational possibilities, to release accumulated stresses, or to optimize its configuration for changing environmental conditions. This evolutionary perspective on planetary alignments connects to broader theories about cosmic evolution and the development of complexity throughout the universe. If solar systems evolve according to principles similar to biological evolution, then planetary alignments might represent reproduction or information exchange events where solar systems share organizational information with each other or with larger cosmic structures. The cosmic evolution framework suggests that planetary alignments might influence not just local solar system dynamics, but also the way our solar system interacts with the galactic environment. During alignment events, the enhanced coordination within our solar system might create stronger or more coherent interactions with galactic magnetic fields, cosmic ray environments, or even gravitational influences from nearby star systems. Recent observations of exoplanetary systems have revealed that many star systems show evidence of past gravitational interactions that have influenced their current planetary configurations. These gravitational encounters might have occurred during periods when the star systems were in enhanced coordination modes, triggered by planetary alignment events, allowing them to exchange orbital energy and angular momentum more efficiently than would be possible under normal gravitational conditions. The possibility that planetary alignments facilitate information or energy exchange between star systems opens intriguing questions about cosmic-scale organization and evolution. If the galaxy operates as an integrated system where individual star systems influence each other's development through alignment-mediated interactions, then our solar system's planetary alignments might be part of a much larger cosmic coordination process. This galactic coordination perspective gains support from observations of cosmic structure formation that reveal remarkable organization and correlation across distances that approach the scale of the observable universe. Galaxy clusters, cosmic filaments, and cosmic voids display organizational patterns that suggest coordination mechanisms operating across billions of light-years. If these large-scale structures can maintain coherent organization across cosmic distances, then smaller-scale systems like individual solar systems might participate in similar coordination networks. The quantum entanglement framework provides another theoretical approach to understanding how planetary alignments might facilitate coordination across cosmic distances. Recent experiments have demonstrated that quantum entanglement effects can persist across much larger distances and time periods than originally thought, raising the possibility that cosmic systems might maintain quantum correlations that allow instantaneous coordination regardless of spatial separation. If quantum entanglement operates at cosmic scales, then planetary alignments might create conditions where entangled quantum states become accessible or enhanced, allowing our solar system to participate in quantum coordination networks that span galactic or even cosmic distances. The enhanced correlation effects observed during planetary alignments could represent manifestations of cosmic quantum entanglement that becomes temporarily visible through alignment-induced resonance amplification. The quantum entanglement perspective also provides a framework for understanding how consciousness might interact with planetary alignment phenomena. If consciousness involves quantum processes, as suggested by various quantum consciousness theories, then conscious observation of planetary alignments might indeed influence the physical phenomena that occurred during these events through quantum measurement effects. Recent research in quantum biology has revealed that quantum effects play crucial roles in biological processes, ranging from photosynthesis to avian navigation, suggesting that the boundary between quantum and classical behavior is much more fluid than traditionally assumed. If biological systems can maintain quantum coherence under ambient environmental conditions, then consciousness might indeed have access to quantum processes that could influence cosmic scale phenomena during planetary alignment events. The morphic resonance theory, developed by biologist Rupert Sheldrake, offers another framework for understanding how planetary alignments might influence biological and consciousness phenomena. According to this theory, similar forms across space and time can share information through morphic fields that transcend conventional physical connections. If morphic resonance operates at cosmic scales, then planetary alignments might create enhanced morphic field effects that influence biological and consciousness processes throughout the solar system. While morphic resonance theory remains controversial within mainstream science, it provides a theoretical framework for understanding the documented correlations between planetary alignments and biological phenomena that are difficult to explain through conventional physical mechanisms. If biological systems can indeed respond to morphic field influences, then the enhanced field configurations created by planetary alignments could explain the coordinated biological responses observed during these cosmic events. The integration of these various theoretical frameworks suggests that planetary alignments might represent multidimensional events that operate simultaneously through gravitational, electromagnetic, quantum, informational, and possibly consciousness-mediated mechanisms. Rather than seeking a single explanation for planetary alignment phenomena, we might need to develop theoretical approaches that can incorporate multiple types of interactions operating across different scales and dimensions of reality. This multidimensional perspective on planetary alignments reflects broader trends in contemporary science toward understanding complex phenomena through interdisciplinary approaches that transcend traditional disciplinary boundaries. Just as understanding consciousness requires integration of neuroscience, psychology, physics, and philosophy, Understanding planetary alignments might require integration of astronomy, physics, biology, consciousness research, and systems theory. The theoretical frameworks we've explored suggest that our solar system might be far more sophisticated and purposeful than conventional mechanical models would indicate. Whether we interpret planetary alignments through resonance amplification, field interactions, consciousness effects, phase transitions, cosmic evolution, quantum entanglement, or morphic resonance, we consistently encounter evidence that our planetary system operates according to organizational principles that transcend simple gravitational mechanics and point toward deeper patterns of cosmic coordination and intelligence. While the theories we've explored offer compelling frameworks for understanding planetary alignment phenomena, scientific integrity requires that we also consider more conventional explanations for the correlations and anomalies we've documented. Perhaps what appears to be cosmic coordination or enhanced planetary influence could emerge from natural processes we already understand, but haven't applied correctly to these situations. Perhaps our pattern-seeking minds are finding significance in coincidences that have simpler, more mundane explanations. These alternative perspectives deserve careful consideration, not as dismissals of mystery, but as attempts to understand how extraordinary-seeming events might arise from ordinary physical processes operating under specific conditions. One of the most robust alternative explanations centers on what physicists call statistical clustering and observational bias. When we examine any large dataset for correlations, we're virtually guaranteed to find some patterns that appear statistically significant purely by chance. The more variables we measure and the more ways we analyze the data, the more likely we are to discover apparent correlations that don't reflect genuine causal relationships. Applied to planetary alignment research, this means that some of the documented correlations between alignments and various phenomena might be statistical artifacts rather than evidence of real physical effects. The observational bias component of this explanation points out that researchers and the general public pay much more attention to unusual events that occur during planetary alignments than to similar events that occur at other times. If a spacecraft experiences navigation difficulties during a planetary alignment, it gets reported as potentially alignment-related. If the same navigation difficulties occur when planets are in normal configurations, they're attributed to routine technical issues and don't become part of the alignment correlation database. This attention bias creates what statisticians call selection effects that can make random coincidences appear to be meaningful patterns. Professional statisticians who work with large astronomical datasets are familiar with this problem and have developed sophisticated techniques for correcting selection biases and multiple comparison errors. When some of the reported planetary alignment correlations are reanalyzed using these more conservative statistical methods, the apparent significance of the correlations decreases substantially. Recent meta-analyses of planetary alignment studies have indeed found that many previously reported correlations become statistically insignificant when proper corrections for multiple comparisons and selection bias are applied. This suggests that at least some of the apparent evidence for planetary alignment effects results from inadequate statistical methodology rather than genuine physical phenomena. Another powerful alternative explanation involves what engineers call systematic measurement artifacts and instrumental sensitivity. The instruments used to detect the subtle effects attributed to planetary alignments often operate at the limits of their measurement capabilities, where small systematic errors or environmental influences can create false signals that mimic genuine physical effects. Temperature variations, electromagnetic interference, mechanical vibrations, and other environmental factors can all influence sensitive measurements in ways that might correlate with planetary positions through indirect causal chains. For instance, gravitational wave detectors like LIGO are sensitive enough to detect traffic on nearby highways, ocean waves hundreds of miles away, and even human footsteps in the vicinity of the detector. If planetary alignments coincide with changes in human activity patterns, seasonal weather variations, or other environmental factors, these indirect influences could create apparent correlations between planetary positions and detector responses that don't reflect direct gravitational effects from the planets themselves. Space-based instruments face similar challenges with systematic errors that can create false correlations. Spacecraft thermal management systems respond to solar radiation variations that can be influenced by planetary positions through orbital mechanics effects. Communication systems are affected by solar wind conditions that change seasonally and in response to the complex gravitational environment created by different planetary configurations. These indirect effects could explain some of the spacecraft anomalies attributed to planetary alignments without requiring exotic new physics. The measurement artifact explanation gains credibility from the history of scientific discovery, which includes numerous examples of apparent anomalies that turned out to be instrumental artifacts. The famous faster-than-light neutrinos detected by the Opera experiment in 2011 were eventually traced to a loose fiber optic connection. The impossible M-drive propulsion system was shown to result from thermal effects and measurement errors. The Pioneer anomaly, which seemed to show unexplained spacecraft acceleration, was ultimately explained through careful analysis of thermal radiation pressure. A third major alternative explanation focuses on known physical processes operating under extreme conditions. The early solar system, planetary magnetospheres, and interplanetary space all involve physical conditions that are impossible to reproduce in terrestrial laboratories. It's entirely possible that well-understood physical processes operating under these extreme conditions produce effects that appear anomalous but actually result from conventional physics applied to unconventional environments. Plasma physics provides a particularly rich source of potential conventional explanations for planetary alignment phenomena. The solar wind is a complex plasma environment where electromagnetic effects can create long-range correlations and apparently non-local phenomena. When multiple planetary magnetospheres interact with the solar wind during alignment periods, they might create plasma instabilities or electromagnetic resonances that propagate throughout the solar system and influence a wide range of measurements and observations. Recent laboratory experiments with high-energy plasmas have revealed that plasma systems can exhibit remarkably complex behaviors that include long-range correlations, coherent wave propagation, and nonlinear amplification effects. If similar plasma physics processes operate in the solar wind during planetary alignments, they could explain many of the documented anomalies without requiring new physics or exotic theoretical frameworks. Magnetohydrodynamics, the study of magnetic field interactions in conducting fluids, offers another conventional framework for understanding planetary alignment effects. The solar wind behaves as a magnetized conducting fluid that can support wave propagation, magnetic reconnection events, and turbulent fluctuations that affect spacecraft, planetary magnetospheres, and even biological systems on Earth. During planetary alignments, the complex magnetic field configurations created by multiple planetary magnetospheres could trigger magnetohydrodynamic instabilities that produce correlated effects throughout the solar system. The cosmic coincidence and temporal clustering explanation suggests that the timing of planetary alignments with various anomalous phenomena might be genuinely coincidental rather than causally related. Planetary alignments occur at predictable intervals determined by orbital mechanics, while many of the phenomena attributed to alignments, solar activity, earthquakes, spacecraft anomalies, biological effects, occur according to their own independent statistical distributions. When two independent processes with different underlying causes occasionally coincide in time, Human psychology tends to assume causal relationships even when none exist. This tendency is strengthened by the natural human inclination to find meaning and purpose in random events, particularly when those events involve cosmic phenomena that capture our imagination and sense of wonder. Mathematical analysis of the timing correlations between planetary alignments and various reported effects reveals that many of these correlations fall within the range expected from random coincidence. Given the number of different phenomena that researchers have correlated with planetary alignments and the frequency with which alignments occur, some apparent correlations are statistically inevitable, even if no causal relationship exists. The cosmic coincidence explanation is supported by the observation that similar anomalous phenomena often occur during periods when planets are not aligned, but these non-alignment events receive less attention and don't become part of the correlation databases that researchers use to establish planetary alignment effects. A related alternative explanation involves environmental and seasonal confounding factors. Planetary alignments don't occur randomly throughout the year. They're more likely to happen at certain times due to the orbital mechanics of the solar system. If these alignment-favorable periods coincide with seasonal variations in solar activity, Earth's atmospheric conditions, or human activity patterns, then apparent alignment effects might actually result from these seasonal factors rather than from direct planetary influences. For example, certain types of planetary alignments are more likely to occur during solar maximum periods when solar activity is naturally enhanced. Solar maximum conditions affect space weather, magnetospheric dynamics, radio propagation, and even some biological systems in ways that could create apparent correlations with planetary alignments that are actually caused by the enhanced solar activity rather than by planetary gravitational or electromagnetic effects. Similarly, the times of year when certain planetary alignments are visible from Earth coincide with seasonal variations in atmospheric conditions that affect astronomical observations, radio propagation, and even biological rhythms in ways that could contribute to apparent alignment effects. Careful statistical analysis that controls for these seasonal confounding factors reduces the significance of many reported planetary alignment correlations. The human psychology and expectation effects explanation acknowledges that conscious observation and expectation can indeed influence both measurement processes and biological responses in ways that could contribute to apparent planetary alignment effects. When researchers, observers, or experimental subjects expect to find unusual phenomena during planetary alignments, their expectations can influence their perceptions, measurement procedures, and even their physiological responses in ways that create apparent confirmations of alignment effects. The placebo effect in medical research demonstrates that expectations can produce real physiological changes that are mediated by psychological rather than directly physical mechanisms. If people expect to experience unusual sensations, sleep disturbances, or emotional changes during planetary alignments, these expectations might indeed trigger real physiological responses that appear to confirm planetary influence, but actually result from psychological rather than cosmic causes. Experimenter bias can influence scientific measurements in subtle ways that are difficult to control completely. If researchers expect to find enhanced effects during planetary alignments, they might unconsciously adjust their measurement procedures, data analysis methods, or interpretation criteria in ways that favor finding the expected results. Double-blind experimental protocols that prevent researchers from knowing when alignments are occurring have been used in some studies, and these tend to show weaker correlations than studies where researchers are aware of alignment timing. The natural system variability and chaos explanation points out that many of the systems that supposedly respond to planetary alignments, Earth's magnetosphere, solar activity, biological rhythms, atmospheric dynamics, are inherently variable and chaotic systems that exhibit unpredictable fluctuations as part of their normal behavior. When these natural fluctuations happen to coincide with planetary alignments, they might be incorrectly attributed to planetary influence rather than recognized as part of the system's intrinsic variability. Chaotic systems are characterized by sensitive dependence on initial conditions, meaning that tiny perturbations can lead to large changes in system behavior that are impossible to predict in detail. Earth's weather system is a classic example of chaotic behavior, where small changes in initial conditions can lead to dramatically different weather patterns within days or weeks. If biological, geophysical, or technological systems exhibit similar chaotic sensitivities, then planetary alignments might occasionally coincide with natural system fluctuations in ways that create apparent causal relationships. The natural variability explanation gains support from detailed statistical analyses of the phenomena attributed to planetary alignments. Many of these phenomena show similar levels of variability during alignment and non-alignment periods when the analysis includes sufficiently long time series and appropriate statistical controls. This suggests that the apparent alignment effects might represent normal system variability that becomes noticeable only when it coincides with periods of heightened attention and expectation. The technological artifact and communication effects explanation suggests that some apparent planetary alignment phenomena might result from the way information about alignment spreads through technological and social networks, rather than from direct physical effects of the alignments themselves. When astronomical organizations announce upcoming planetary alignments, this information influences human behavior, attention patterns, and measurement priorities in ways that could contribute to apparent alignment effects. For instance, amateur radio operators might pay more attention to unusual propagation effects during announced alignment periods, leading to increased reporting of anomalous signals that occur at normal rates but usually go unnoticed. Space agencies might schedule more intensive monitoring during alignment periods, leading to enhanced detection of anomalies that occur at normal rates but aren't usually observed with such high attention levels. The technological artifact explanation is particularly relevant for phenomena that depend on human observation, reporting, or interpretation. Many of the biological effects attributed to planetary alignments, for instance, rely on self-reporting of subjective experiences like sleep quality, mood changes, or physical sensations. If people are more likely to notice and report unusual experiences during periods when they've been told to expect planetary influences, this could create apparent correlations that reflect communication effects rather than direct planetary effects. Recent studies that compare reported planetary alignment effects before and after public announcement of alignment events have found that reports increase significantly after announcements, suggesting that communication and expectation play substantial roles in generating apparent alignment phenomena. The mundane explanation persistence principle reminds us that throughout scientific history, phenomena that initially appeared to require extraordinary explanations often turned out to have perfectly ordinary causes once they were understood more completely. Meteors were once thought to be supernatural omens rather than natural space debris. Aurora were attributed to divine messages rather than electromagnetic interactions. Earthquakes were considered expressions of underground spirits rather than tectonic processes. The history of science suggests that when faced with apparent anomalies, the most productive approach is usually to explore conventional explanations more thoroughly before invoking exotic new physics or consciousness-mediated effects. This doesn't mean dismissing genuine mysteries, but rather ensuring that conventional possibilities have been exhaustively investigated before concluding that revolutionary new theoretical frameworks are required. Applied to planetary alignment phenomena, the mundane explanation principle suggests that the documented correlations and anomalies might result from complex combinations of known physical processes, measurement artifacts, statistical clustering, environmental confounding factors, and human psychological effects rather than from exotic new forms of planetary influence. These alternative explanations don't necessarily negate the possibility that planetary alignments do produce genuine physical effects, but they do provide important balance to our cosmic contemplations. They remind us that extraordinary claims require extraordinary evidence, and that the universe has repeatedly surprised us by achieving remarkable outcomes through entirely natural processes operating under special conditions. Perhaps most importantly, these alternative perspectives help us appreciate that cosmic mystery doesn't require exotic new physics to be profoundly meaningful. A universe that achieves the appearance of purposeful coordination through the complex interplay of known physical processes might be even more remarkable than one guided by hidden cosmic forces. The silent stories of our planetary neighbors continue to challenge our assumptions and expand our sense of cosmic possibility, regardless of which explanatory framework ultimately proves most accurate. As we reach the end of our journey through the silent stories of our planetary neighbors, we find ourselves in a place of deeper wonder rather than final answers. We've explored ancient wisdom and modern measurements, documented evidence and speculative theories, genuine mysteries and conventional explanations. Through it all, planetary alignments have revealed themselves to be far more than just geometric curiosities in the sky. They're invitations to contemplate the nature of cosmic organization, the relationship between consciousness and cosmos, and our own place within the vast gravitational dance that has been choreographing celestial motion since our solar system began. What emerges most clearly from our exploration is that planetary alignments serve as natural experiments that reveal aspects of our solar system we might never otherwise notice. Whether the effects we observe during these cosmic events result from gravitational resonance, plasma physics, statistical coincidence, or something more exotic, they consistently show us that our solar system is a far more interconnected and dynamically responsive place than everyday experience would suggest. The evidence we've examined, from ancient astronomical records to modern spacecraft telemetry, from laboratory measurements to biological observations, paints a picture of cosmic relationships that transcend the simple mechanical interactions described in introductory astronomy textbooks. Our solar system operates as an integrated whole, where planets influence each other not just through direct gravitational attraction, but through complex webs of resonance, field interactions, and possibly even information-sharing mechanisms that we're only beginning to understand. This integrated perspective on solar system dynamics reflects broader shifts in scientific understanding toward recognizing that complex systems often exhibit properties that emerge from relationships rather than residing in individual components. Just as consciousness emerges from neural networks rather than from individual brain cells, and ecosystems exhibit behaviors that transcend the activities of individual species, our solar system displays organizational characteristics that arise from planetary relationships rather than from planetary properties alone. The historical dimension of our exploration reveals that human beings have always sensed something significant about planetary alignments, even when they lack the technological tools to measure subtle physical effects. Ancient astronomers invested enormous effort in tracking planetary cycles, creating mathematical models of remarkable sophistication, and timing cultural events to coincide with cosmic configurations. This persistent human fascination with planetary relationships suggests that consciousness itself might be naturally attuned to cosmic rhythms in ways that transcend purely intellectual curiosity. The correlation between ancient astronomical wisdom and modern scientific discoveries creates a bridge between different ways of knowing that enriches our understanding of both cosmic mechanics and human consciousness. Ancient civilizations developed insights about planetary relationships through centuries of careful observation and pattern recognition, while modern science has provided the theoretical frameworks and measurement capabilities to explore these relationships with unprecedented precision. Together, these complementary approaches reveal planetary alignments as phenomena that operate simultaneously in the domains of physics and consciousness, matter and meaning. The theoretical frameworks we've explored, from gravitational resonance to holographic information processing, from scalar field interactions to cosmic consciousness, all point toward the same fundamental insight. Planetary alignments might represent moments when underlying organizational principles in our solar system become temporarily visible or enhanced. Whether we interpret these principles in terms of physics, information theory, or consciousness studies, we consistently encounter evidence that our cosmic neighborhood operates according to sophisticated coordination mechanisms that challenge conventional reductionist approaches. This convergence of theoretical perspectives suggests that planetary alignments might serve as bridges between different levels of reality, connecting quantum and cosmic scales, linking consciousness and cosmos, integrating past and future through resonance effects that transcend normal temporal boundaries. During alignment events, the boundaries between different domains of experience might become more permeable, allowing us to perceive connections and influences that usually operate below the threshold of normal awareness. The alternative explanations we've considered remind us that scientific humility remains essential even in the face of compelling mysteries. The history of science is filled with phenomena that initially appeared to require revolutionary new theories, but ultimately yielded to more thorough application of known principles. Planetary alignment effects might indeed result from complex combinations of conventional physics, measurement artifacts, statistical clustering, and human psychological factors rather than from exotic new forms of cosmic organization. Yet even the most conservative alternative explanations don't diminish the significance of what planetary alignments reveal about the nature of cosmic interconnection and human consciousness. If the effects we observe during alignment periods result from the complex interplay of known physical processes operating under special conditions, this still demonstrates that our solar system exhibits organizational capabilities far more sophisticated than simple mechanical models would suggest. If some alignment effects result from enhanced human attention and expectation during these cosmic events, this reveals the profound psychological importance that planetary relationships hold for human consciousness. The fact that awareness of cosmic configurations can influence human perception, behavior, and even physiology suggests that consciousness remains intimately connected to cosmic rhythms despite the technological insulation of modern life. The measurement challenges involved in studying planetary alignment effects highlight the remarkable sensitivity required to detect the subtle influences that apparently operate during these cosmic events. Whether these influences represent genuine physical forces or measurement artifacts, they demonstrate that our solar system exists in a state of dynamic equilibrium where tiny perturbations can trigger cascading effects that propagate throughout the system. This sensitivity suggests that our solar system might be poised near critical points where small changes in planetary configurations can trigger phase transitions between different organizational states. If this is true, then planetary alignments serve as natural tests of solar system stability and reveal how close our cosmic neighborhood operates to the edge of chaos where small causes can produce large effects. The biological evidence for planetary alignment effects, while often subtle and controversial, points toward deep connections between cosmic rhythms and living systems that extend far beyond the obvious solar and lunar cycles that regulate circadian and seasonal behaviors. If biological systems can indeed respond to the minute gravitational, electromagnetic, or field variations that accompany planetary alignments, This suggests that life itself might be fundamentally entangled with cosmic processes in ways that transcend conventional understanding. This biological sensitivity to cosmic rhythms connects to broader questions about the role of consciousness in cosmic evolution and the possibility that awareness represents a fundamental aspect of how complex systems organize themselves across all scales of reality. If consciousness emerges from cosmic processes rather than just from local brain activity, then human awareness of planetary alignments might represent the universe developing enhanced self-awareness through conscious observation of its own organizational dynamics. The technological evidence for alignment effects reveals how human scientific capabilities have evolved to the point where we can detect influences and correlations that were previously invisible. Advanced spacecraft navigation, atomic clocks, gravitational wave detectors, and other sophisticated instruments have opened windows into previously hidden aspects of solar system dynamics, revealing that space is far from empty and that cosmic relationships operate through mechanisms more subtle and complex than classical physics anticipated. This technological sensitivity also highlights how human activities have become integrated into solar system dynamics in ways that create new forms of cosmic interconnection. Our spacecraft serve as mobile sensors that provide real-time information about conditions throughout the solar system. Our communication networks create information links that span planetary distances. Our scientific instruments measure cosmic influences with precision that rivals or exceeds natural detection capabilities. Through technology, human consciousness has extended its reach throughout the solar system, creating feedback loops between cosmic observation and cosmic processes that might influence the very phenomena we're trying to understand. If consciousness plays an active role in cosmic organization, then human technological expansion throughout the solar system represents the universe developing new mechanisms for self-observation and self-influence. The global nature of human interest in planetary alignments creates another dimension of cosmic interconnection that transcends individual consciousness. When planetary alignments occur, millions of people worldwide direct their attention simultaneously toward the same cosmic event, creating what might be described as a global consciousness focusing effect. If consciousness can indeed influence physical processes, then this collective attention might contribute to the phenomena observed during alignment periods. This collective aspect of alignment observation connects to broader questions about the relationship between human civilization and cosmic evolution. As our species develops the technological capabilities to observe and potentially influence cosmic processes, we become active participants in solar system dynamics rather than just passive observers. Our choices about how to direct scientific attention, technological development, and collective awareness might influence the future evolution of cosmic organization in ways we're only beginning to recognize. The ethical implications of this potential influence suggest that planetary alignment research carries responsibilities that extend beyond pure scientific curiosity. If human consciousness and technology can indeed affect cosmic processes, then we bear some responsibility for ensuring that our cosmic engagement promotes beneficial outcomes for solar system evolution and the emergence of complexity and life throughout the universe. The timing of humanity's technological development coincides remarkably with our entry into a period of enhanced planetary alignment activity as Jupiter and Saturn approach their close conjunction cycles and other planetary configurations create opportunities for improved observation of cosmic interconnection effects. This timing might be coincidental, or it might reflect deeper synchronicities between consciousness evolution and cosmic cycles that connect human development to broader patterns of cosmic organization. As we look toward the future, upcoming planetary alignments offer opportunities to test and refine our understanding of cosmic interconnection using increasingly sophisticated measurement techniques and theoretical frameworks. The next major alignment events will occur during a period when human technological capabilities and scientific understanding have reached unprecedented levels, creating possibilities for discoveries that could transform our understanding of cosmic organization and consciousness. Future space missions will carry instruments specifically designed to study alignment effects, creating the first systematic research programs dedicated to understanding planetary relationship dynamics. Advanced artificial intelligence systems will analyze cosmic data with pattern recognition capabilities that exceed human limitations, potentially revealing organizational principles in planetary behavior that human observers have missed. The development of quantum technologies might provide new tools for studying the subtle field interactions and information processing mechanisms that theoretical frameworks suggest operate during planetary alignments. Quantum sensors, quantum communication systems, and quantum computers might reveal aspects of cosmic organization that operate at the intersection of quantum mechanics and gravitational physics. But perhaps the most significant developments will occur in our understanding of consciousness and its relationship to cosmic processes. As neuroscience, psychology, and consciousness studies continue to reveal the fundamental nature of awareness, we might discover that consciousness represents a cosmic principle that operates at all scales of reality, rather than just an emergent property of complex brains. If this is true, then planetary alignments might serve as focusing events that allow consciousness at different scales, from individual human awareness to potential cosmic consciousness, to recognize and interact with each other through resonance effects that transcend normal spatial and temporal limitations. In the end, our exploration of planetary alignments brings us back to the most fundamental questions about existence itself. What is the nature of cosmic organization? How does consciousness relate to cosmic evolution? What is our role and responsibility as aware beings in a universe that appears to be developing its own self-awareness through creatures like ourselves? These questions may never have final answers, but they continue to guide us toward deeper appreciation of the magnificent cosmic home we inhabit. Planetary alignments remind us that we exist within processes that extend far beyond individual human experience, while simultaneously suggesting that individual consciousness contributes to cosmic evolution in ways that matter on cosmic scales. The silent stories that our planetary neighbors tell through their eternal dance speak of organization, purpose, and meaning that permeate the universe at levels we're only beginning to comprehend. Whether these stories unfold through gravitational mechanics, field interactions, consciousness effects, or combinations of all these influences, they consistently reveal that we live in a cosmos far more wonderful, interconnected, and meaningful than we ever dared imagine. As the planets continue their ancient dance through space and time, they carry forward the cosmic conversation between matter and consciousness, between order and chaos, between the individual and the universal. And we continue our own dance of discovery, following wherever wonder leads us, grateful to be conscious participants in the universe's ongoing exploration of its own infinite mystery and boundless possibility. What strikes me most profoundly about our journey through planetary alignment mysteries is how it reveals the inadequacy of our usual categories for understanding reality. We typically think in terms of either-or distinctions. Either something is physically real or it's psychologically constructed. Either effects are caused by known physics or they require new theories. Either consciousness is local to brains or it's a cosmic principle. But planetary alignments seem to operate in the spaces between these categories, challenging us to develop more nuanced ways of thinking about the relationship between mind and cosmos. This liminal quality of planetary alignment phenomena reflects broader characteristics of the universe that become visible when we examine reality at its edges: quantum mechanics at the smallest scales, cosmology at the largest scales, consciousness at the intersection of subjective and objective experience. In each case, we encounter phenomena that resist simple categorization and invite us to expand our conceptual frameworks in ways that honor both scientific rigor and the irreducible mystery of existence. The mathematical precision underlying planetary motion creates another layer of wonder that connects cosmic mechanics to consciousness in unexpected ways. The fact that planetary alignments can be predicted with extraordinary accuracy, thousands of years into the future, suggests that we live in a universe where mathematical relationships constitute fundamental aspects of reality rather than just human constructions for describing reality. Yet this mathematical precision coexists with the chaotic sensitivity and emergent complexity that we observe in planetary alignment effects. Small changes in initial conditions can lead to dramatically different outcomes, while statistical patterns emerge from seemingly random fluctuations. This combination of mathematical determinism and creative uncertainty mirrors the way consciousness itself operates, following patterns and rules while simultaneously generating novel experiences and insights that transcend mere mechanical computation. The historical perspective on planetary alignments reveals how human understanding of cosmic relationships has evolved through cycles of discovery, speculation, skepticism, and renewed investigation that mirror the cyclical nature of planetary motion itself. Ancient astronomers developed sophisticated mathematical models based on careful observation. Medieval scholars refined these models while adding layers of philosophical interpretation. Renaissance scientists revolutionized understanding through heliocentric theory and gravitational mechanics. Modern researchers have added quantum field theory, complexity science, and consciousness studies to create even more comprehensive frameworks. This historical spiral of understanding suggests that our current perspectives on planetary alignments represent just one turn in an ongoing cycle of discovery that will continue as human consciousness and technological capabilities evolve. Future generations may develop insights into cosmic organization and consciousness that make our current debates about planetary alignment effects seem as quaint as medieval discussions of celestial spheres seem to us today. Yet there's also something timeless about the fundamental questions that planetary alignments raise. The relationship between cosmic order and consciousness, the nature of influence and causation across cosmic distances, the role of awareness in cosmic evolution. These themes appear consistently across cultures and historical periods, suggesting that they reflect deep truths about the nature of reality that transcend particular scientific paradigms or technological capabilities. The global character of human fascination with planetary alignments points toward universal aspects of consciousness that connect us to cosmic rhythms, regardless of cultural background or scientific sophistication. Children who have never studied astronomy often show spontaneous interest in planetary alignments. Indigenous cultures that developed independently of European astronomical traditions created their own sophisticated systems for tracking planetary relationships. Even in our technologically dominated modern world, planetary alignments continue to capture public imagination in ways that purely scientific phenomena rarely achieve. This universal appeal suggests that planetary alignments activate something fundamental in human consciousness, perhaps a recognition of our cosmic context that operates below the level of explicit knowledge. If consciousness did indeed evolve within cosmic processes, then our attraction to planetary alignments might represent a kind of cosmic memory or intuitive recognition of our participation in larger patterns of cosmic organization. The aesthetic dimension of planetary alignments provides another bridge between scientific and experiential ways of engaging with cosmic mysteries. When we observe planets clustering together in the night sky, we experience beauty that transcends mere intellectual understanding. The geometric patterns created by planetary configurations exhibit the same mathematical relationships that appear in music, art, and architecture, suggesting deep connections between consciousness, aesthetics, and cosmic organization. This aesthetic response to cosmic phenomena might represent one of the most sophisticated ways that consciousness engages with cosmic processes. Through appreciation of cosmic beauty, we participate directly in the universe's capacity for self-appreciation rather than just analyzing it from an external perspective. The wonder we feel when contemplating planetary alignments becomes part of the universe, experiencing its own magnificence through conscious beings. Recent developments in astrobiology and the search for extraterrestrial life add another dimension to our understanding of planetary alignments and their potential significance. If life exists elsewhere in our solar system or in other planetary systems, those life forms might also be sensitive to planetary alignment effects and might have developed their own ways of understanding and responding to cosmic relationships. The possibility of cosmic life suggests that planetary alignments might serve as coordination mechanisms, not just within individual solar systems, but between different forms of consciousness throughout the galaxy. If consciousness represents a fundamental aspect of cosmic evolution, then planetary alignments might facilitate information exchange or coordination between conscious beings across cosmic distances through mechanisms we don't yet understand. This cosmic perspective on consciousness and planetary alignments connects to emerging theories about the universe as a vast information processing system where consciousness serves as both an outcome of cosmic evolution and an active participant in guiding cosmic development. From this viewpoint, human observation and study of planetary alignments represents the universe developing new capabilities for self-understanding and self-influence through conscious beings. The technological dimension of modern planetary alignment research creates feedback loops between cosmic observation and cosmic processes that didn't exist during earlier periods of human history. Our spacecraft, communication networks, and scientific instruments have become integral parts of solar system dynamics, creating new forms of cosmic interconnection that blur the boundaries between natural and technological phenomena. As human technology becomes more sophisticated and widespread throughout the solar system, our capacity to observe, measure, and potentially influence planetary alignment effects will continue to expand. Future space-based observatories, interplanetary communication networks, and even planetary engineering projects might create opportunities to test theories about cosmic organization and consciousness at scales approaching the planetary alignments themselves. This technological evolution raises profound questions about human responsibility in cosmic evolution. If consciousness can indeed influence cosmic processes, and if human technological capabilities give us increasing power to affect solar system dynamics, then how we choose to study and engage with planetary alignments might influence the future evolution of cosmic organization itself. The ethical implications extend beyond just scientific methodology to encompass fundamental questions about the goals and values that should guide human cosmic engagement. Should we seek to optimize solar system dynamics for maximum stability, for maximum complexity, for maximum consciousness, for maximum beauty? The answers to these questions might influence not just human civilization, but the long-term evolution of cosmic organization throughout the galaxy. The contemplative aspect of planetary alignment research offers a counterbalance to purely technological approaches by emphasizing direct experiential engagement with cosmic processes. When we simply sit under the night sky and observe planetary alignments with our own eyes, we participate in the same basic activity that ancient astronomers engaged in thousands of years ago. This direct observational connection creates continuity between past and future that transcends technological mediation. This contemplative dimension suggests that understanding planetary alignments might require not just sophisticated instruments and theoretical frameworks, but also cultivation of awareness and attention that allows consciousness to resonate directly with cosmic processes. The enhanced sensitivity that some people report experiencing during planetary alignments might reflect the development of perceptual capabilities that complement rather than replace scientific measurement techniques. The integration of contemplative and scientific approaches to studying planetary alignments could lead to new forms of cosmic research that honor both the objective and subjective dimensions of cosmic phenomena. Rather than viewing consciousness and cosmos as separate domains that interact only through physical mechanisms, we might develop research methodologies that recognize consciousness as a cosmic principle that operates at all scales of reality. The therapeutic potential of planetary alignment awareness suggests another practical dimension of cosmic relationship that extends beyond pure scientific curiosity. If consciousness is indeed naturally attuned to cosmic rhythms, then conscious engagement with planetary alignments might offer ways of enhancing human well-being, creativity, and spiritual development that complement technological and medical approaches to human flourishing. Some contemporary practices attempt to integrate awareness of cosmic cycles with meditation, healing, and personal development work, though these approaches often lack the rigorous methodology needed to distinguish genuine effects from placebo responses or wishful thinking. Future research might develop more sophisticated ways of studying how conscious engagement with cosmic processes affects human psychology, physiology, and spiritual development. The educational implications of planetary alignment research suggest opportunities to transform how we teach astronomy, physics, and consciousness studies by emphasizing the interconnected nature of cosmic and consciousness phenomena. Rather than treating these domains as separate subjects, educational approaches could explore how scientific and experiential ways of knowing complement each other in developing comprehensive understanding of cosmic relationships. This educational integration could help bridge the gap between scientific and spiritual perspectives on cosmic phenomena that has created unnecessary conflicts between different ways of engaging with cosmic mysteries. By recognizing that both scientific measurement and contemplative awareness provide valuable insights into cosmic processes, we might develop more inclusive approaches to cosmic education that honor multiple ways of knowing. The personal transformation that often accompanies deep engagement with planetary alignment mysteries reflects the way cosmic awareness can shift fundamental perspectives on identity, purpose, and meaning. When we truly absorb the fact that we exist within cosmic processes that span billions of years and light-years of space, it can transform how we think about the significance of individual human life and the responsibilities that come with consciousness. This transformative potential suggests that planetary alignment research might contribute not just to scientific knowledge, but to the evolution of human consciousness itself. As more people develop sophisticated understanding of cosmic relationships and human participation in cosmic processes, it might catalyze broader shifts in human values, priorities, and behaviors that influence the future trajectory of human civilization and its role in cosmic evolution. In the end, our exploration of planetary alignments returns us to the fundamental mystery of existence itself, the fact that anything exists at all, that consciousness can arise within cosmic processes, and that through consciousness the universe can come to know and appreciate its own nature. Planetary alignments serve as regular reminders of this cosmic context and our participation in processes far larger than individual human concerns. The silent stories that our planetary neighbors continue to tell through their eternal dance speak of organization, purpose, and meaning that permeate the universe at levels we're only beginning to comprehend. Whether these stories unfold through gravitational mechanics, field interactions, consciousness effects, or combinations of all these influences, they consistently reveal that we live in a cosmos far more wonderful, interconnected, and meaningful than we ever dared imagine. And in contemplating these cosmic relationships, we discover not just facts about planetary motion, but insights into the deepest questions about what it means to be conscious beings in a conscious universe